If you understand mole ratios, but you aren't sure how to use them in actual problems, this video is going to walk you through mole to mole stoichiometry step by step. So let's start with what is stoichiometry anyway? Well, it's the mathematical relationship found in balanced chemical equations. So if we know the quantity of any one substance in a balanced equation, whether it be a reactant or a product, we can find the quantities of all the other substances using the process of stoichiometry. So stoichiometry follows several kind of key steps, and we'll see that as we're kind of building through our problems today. And so the first step is going to be a balanced chemical equation, followed by identifying what we're given and what we're looking for. We're going to set up a mole ratio and then solve for our unknown. So in our equation here, for example, we have two H2s and we have an O2, and that's going to react to give us two water molecules. So if we are given information about any one of these substances within our reaction, say we're given the number of moles of oxygen, then we can find the moles of hydrogen and the moles of water using the process of stoichiometry. So let's just jump into some examples and see how this works. Our first example here then says aluminum bromide can be prepared by reacting small pieces of aluminum foil with liquid bromine at room temperature. So I'm just going to highlight, underline our compounds that we are reacting with here. How many moles of bromine are needed to produce 5 moles of aluminum bromide if sufficient aluminum is present? So the first step in stoichiometry is always a balanced chemical equation. So let's start with that. We're given that aluminum foil, so that's going to be solid aluminum, is reacting with liquid bromine. Remembering that bromine's one of our diatomics, so it's always Br2, and that's going to produce our aluminum bromide. So AlBr3. And not given a state there, but I know that it's a solid. So this is our skeleton equation. We need to balance it. So if we have bromines, let's balance those first by putting a 3 and a 2 there. And then to balance the aluminum, we need a 2 there. Okay, we're balanced. We've got our balanced chemical equation. Now, it can be really helpful to go in with a highlighter here and highlight, okay, we are given moles of aluminum bromide, so that's this one here. And we are looking for moles of bromine, so that's this one here. And we're given moles, so we're going to set up our mole ratio at this point. So remember, setting up our mole ratio, we're going to set up our known values on one side. So 3 moles of Br2 produces 2 moles of AlBr3. And then we're going to set up our values from our problem. So we've got 5 moles of AlBr3. That's on the bottom on that side, so we make sure it's on the bottom this side. And then we're trying to find moles of bromine. So we got moles of bromine on the top, so we're going to put moles of bromine on the top here too. Okay, double check that, make sure that those match. From here, we're going to solve for x using cross multiplication. So x times 2 is 2x. And then we got 3 times 5, which is 15. And then if we divide both sides by 2, we have 15 divided by 2, or also that is 7.5 moles of Br2 is needed. So we've just done mole-to-mole stoichiometry. We were given moles of one substance and we found the moles of another substance within our balanced chemical equation. And it is that easy. So we're going to balance, then we're going to use our mole ratio and find our answer. And that is our key steps of stoichiometry. Let's work through another example here. So we've got ethane is undergoing complete combustion to produce carbon dioxide and water. How many moles of oxygen are required to react with 13.9 moles of ethane? Let's start with step one and balance our chemical equation. Now, this one's a little bit trickier because it's a complete combustion. So we're reacting with oxygen gas, and it says we're producing carbon dioxide, that's a gas, and water, liquid. Balancing this equation here, then, if we work through the steps, and I'm not going to work through the steps in this problem, but we would have 2, 7, 4, and 6. Can be worthwhile if you pause the video there and just go try that for yourself and make sure you get that balanced. If you're unsure about balancing, I will be creating a video at some point in the near future on balancing, and you can go check that one out. When I have that ready, I will link that in the description for this video. But getting back to it. Okay, we've got our balanced chemical equation. Let's take our handy dandy highlighter and highlight that we're given moles of ethane. So that's here in our balanced chemical equation. And then we are looking for moles of oxygen. So that's given here in our equation. Let's set up our mole ratio then. So this is step 2. And we know that for 2 moles of ethane from our balanced chemical equation, we need 7 moles of O2. And the problem gives us 13.9 moles of ethane. So ethane was on the top on that side, so we're putting it on the top here. And then X moles of O2. Okay, cross multiplying again. We get 2x is 13.9 times 7. And so if we do that math, we divide both sides by 2. Then X is equal to 48.7 moles, and that's oxygen gas is required. Okay, so we followed the steps again and completed our calculation. Now, part B of this question asks us now how many moles of water would be produced by 1.4 moles of oxygen gas and sufficient ethane. So again, let's take our highlighter. We're given moles of oxygen gas, so we're given this one this time, and we are looking for moles of water. So we're looking for this one on this side. So sometimes you might be doing mole ratios between both of the reactants, sometimes between a reactant and a product, could be between 2 products. It doesn't matter as long as we're kind of highlighting and figuring out what we're setting our mole ratio up for. We should be good, and it's pretty easy to set that up. So we've got 7 moles of O2, and we got 6 moles of water. That's from our balanced chemical equation. And we're given 1.40 moles of oxygen. And we're trying to find the moles of water. Double check, O2 is on top, both waters are on the bottom, so we're good to go. We can cross multiply. So 7 times x is 7x. And then we've got 6 times 1.4. And so if we do that, we divide both sides by 7. X is going to give us 1.2 moles of water produced. Okay. Now, we should be checking significant digits too. So let's kind of go back here. We've got 3 significant digits. It is significantly difficult to say significant digits, apparently. But we have 3 significant digits here, and we've just multiplied or divided here. You don't consider the whole numbers for mole ratios in your significant digits, so we should have 3 sig digs in our answer, which is why I'm adding the 0 in there. Okay, so it is that easy. If you always follow the same core steps, stoichiometry becomes really easy and actually very formulaic to solve. In the next video then, We're going to extend this to stoichiometry problems where the quantities are given in molecules or atoms instead of moles. That video is linked on the screen and in the description. Go check it out now, and I'll see you there.